For many years, artificial intelligence has been evaluated primarily by one single question.
Can it reason?
Now, as AI systems have become more and more capable over the years, they've learned to do some truly incredible things, right? I mean, solving complex mathematical problems, writing software from scratch, answering deep scientific questions, and even performing long, complicated chains of logical reasoning. These achievements are absolutely remarkable. There is just no denying it. Reasoning is undoubtedly one of the core foundations of intelligence.
But is reasoning alone enough?
Section 1. The limits of reasoning. The bicycle analogy.
So, to really explore the limits of reasoning, I want you to imagine asking someone to learn how to ride a bicycle without ever actually touching one. You know, a person could read every single physics textbook out there. They could memorize all the engineering principles. They could sit down and perfectly explain balance, momentum, and steering to you. They can reason through the entire concept of riding. But none of that theoretical reasoning actually guarantees capability. Eventually, they'd literally just have to get on the bicycle.
Move, fall, adjust, try again. Learning emerges through interaction. Take a moment to just let that fundamental truth sink in, because at the end of the day, you cannot simply think your way into physical balance.
Section 2. Learning through interaction. Imagination versus the real world.
See, this exact same principle applies directly to intelligent systems. Reasoning allows a system to imagine possibilities. It basically lets an AI build a model in its head, so to speak, of what might happen. But it's the real world, the actual environment, that determines which of those possibilities are correct. Reasoning builds the map, sure, but the real world is the actual territory.
Think about it this way. Every single action an intelligent system takes produces new information. Now, sometimes the result perfectly confirms the prediction the reasoning model made, but other times, it completely surprises the system. And this is exactly what you should take away from this explainer today. Those surprises are not failures. Actually, they are essential parts of learning.
Section 3. The continuous cycle. Reasoning in the environment.
This dynamic right here creates an absolutely crucial continuous cycle. If you contrast the straight line of long-chain reasoning, where a system literally just sits there and thinks, with a continuous circular loop, you'll see how true intelligence really operates. It goes like this. The system reasons, it explores and acts, then the environment responds by sending a signal back. That new information updates the system's understanding, and then, well, it reasons again. Each cycle makes the next decision so much better informed.
Without interaction, reasoning remains hypothetical. Without reasoning, interaction becomes random. Neither is sufficient by itself. True intelligence requires both.
Section 4. Beyond artificial intelligence. A continuous conversation.
This philosophical idea actually extends far beyond artificial intelligence. Scientists do not only think, they perform experiments. Engineers do not only design, they build prototypes. Doctors do not only study diseases, they observe patients and adjust treatments. I mean, penicillin wasn't discovered purely through theoretical reasoning, but because Alexander Fleming observed a surprising reaction in a dirty petri dish. In every field, progress comes from a continuous conversation between thinking and reality.
Section 5. The future of AI. Understanding and experience.
So, what does this all mean for the future of AI? Well, the exact same rules we just saw for doctors and scientists apply right here. As models become increasingly capable, their success may depend a lot less on just producing longer reasoning chains and a whole lot more on maintaining continuous interaction with the world around them.
It all really comes down to this core interactive loop. Reasoning generates hypotheses. Action tests those hypotheses. Feedback reshapes understanding. Reasoning begins again.
Intelligence is not a straight line of increasingly complex thoughts. It is a continuous cycle between understanding and experience. The future of AI might therefore depend not only on how well it thinks, but on how effectively it learns from the real consequences of its own actions.
Which leaves us with one incredibly vital, profound question to consider. If intelligence depends on continuous interaction, how can an AI system remember what truly matters across thousands of future decisions?